All right, good morning. Today we're going to talk about the graphs of sine and cosine, specifically focusing on sine and cosine first. Later we'll take a look at tangent and cotangent and secant and cosecant. But a lot of the applications, a lot of the things that we'll be doing, a lot of the things that we use, mostly focus on using sine and cosine. Those seem to be very important. And I'd like to do these kind of by brute force. What we're going to do is we're going to pick different values and plug them in and then graph it and see, well, what does it look like? All right, so I want to graph the function y is f of x, which is the sine of x. And I want to graph it over the interval from negative 2 pi to positive 2 pi. And I'm going to create a data table, and we're going to plug numbers in for x, calculate the sine of x, and then actually do a graph of this thing. So the data table is going to be kind of big here, so make sure we got plenty of room. I'm going to pick x values here and the sine of x here. And we're going to go from negative 2 pi to positive 2 pi, and we're going to use all of our nice, well-behaved reference angles. Well, what do I mean by nice, well-behaved reference angles? Well, if I draw myself a little kind of a cheat sheet over here, a unit circle, and I know that on my unit circle, I've got, and I want to think in radians now, 0 pi, pi over 2 pi, 3 pi over 2, and 2 pi. And I know the corresponding coordinates of each of these points. This point is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. I know it's getting kind of small up there. Sorry about that. I want to make sure we leave plenty of room down here, though. So now I'm going to use all of these angles. So I'm going to start at negative 2 pi. And we'll fill in the sine values in a moment. Negative 3 pi over 2. Negative pi. Negative pi over 2. 0 pi, positive pi over 2, positive pi, 3 pi over 2, and positive 2 pi. And I want to put in the corresponding x values, the sine values. Now remember, the sine is the y value over the r value. In the unit circle, the radius is 1, so really the sine is just the y value. So at negative 2 pi, if I start here and go negative 2 pi, I'm here. What's the y value right there? 0. If I go negative 3 pi over 2, start here, go negative 3 pi over 2, there I am. What is the y value there? 1. Go negative pi, what's the y value there? 0. Go negative pi over 2, there I am. What's the y value? Negative 1. 0 pi, what's the y value? 0. Pi over 2, what's the y value? 1. At pi, what's the y value? 0. At 3 pi over 2, what's the y value? Negative 1. And at 2 pi, what's the y value? 0. So now I'm going to graph this. It might not look like much, but it's all going to come together here in a moment. So I'm going to graph. And it looks like my range goes from negative 1 to positive 1. And I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2. Extend that a little bit here. And negative 2 pi. And now let's graph all of these points. So at negative 2 pi, it's 0. At negative 3 pi over 2, it's 1. At negative pi, it's 0. At negative pi over 2, it's negative 1. At 0 pi, it's 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So it doesn't look like much, but watch what happens when I connect this curve here. I get a nice... And of course, I'm going to draw the little arrows indicating it keeps going. And there it is. That's my sine curve. There is sine. Let's take a look at it and talk about sine for a moment. What's its domain? What's the domain of sine? Well, are there any restrictions? Is there anything I'm not allowed to plug in? No. So the domain is all real numbers. What's the range? Well, it looks like my smallest I ever get is negative 1. Oh, there should be a negative there, shouldn't there? I didn't put a... oh, look at that. I put a negative there and a positive there. That should be negative. That should be positive. Did you catch that? Are you making fun of me because of that? That should be the negative 1 down here is the negative 1, and that should be the positive 1 up there. So the range goes from negative 1 to positive 1. How about the end behavior? As x is increasing without bound, what is this function doing? Is it approaching anything? Well, not really. It seems like half the time it's getting closer and closer to 1, and then it's getting closer and closer and closer to negative 1, and then getting closer and closer and closer to 1, and then closer and closer to negative 1, and closer and closer to 1. It's oscillating between negative 1 and positive 1. So it doesn't really have any end behavior. We cannot say it approaches any number at all. When we talk about the end behavior. The other thing that I want you to notice is that this pattern, it repeats. It's a repeating pattern. Can you see that if we kept going, it would just keep going, it would keep going, keep going, keep going like that forever. Kind of up and down, up and down, up and down forever. We call this a periodic function. It has a period to it. It repeats, the pattern repeats every period. Well, what is the period here? Well, if I take a look from 0 to 2 pi, notice I get this curve here, and it's a repeating pattern. This pattern is repeated here. So we say that the period of this function is 2 pi, because every 2 pi, the pattern just keeps repeating forever. Forever and ever and ever and ever. All right, so now let's do the same thing with cosine. And we're going to take a closer look at it, and then we'll compare sine and cosine when we're done. All right, so here we go. Cosine now. If you want to, if you feel pretty confident, you know what you're doing, see if you can stay ahead of me on this one. Y equals f of x, which is the cosine of x. And again, I'm going to do it from negative 2 pi to positive 2 pi, and again I'm going to draw my little unit circle over here to kind of help me decide what's what. In my unit circle, I know I'm going to have 0 pi, pi over 2 pi, 3 pi over 2, and 2 pi, and 0 pi are the same. Going backwards are the negative numbers. And the coordinates, I know I'm going to need the coordinates here in a moment. The coordinate here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And now the table, we're going to have to make that table again. So we're going to have the x values here. But this time we're going to have the cosine of x. We're going to do the same domain from negative 2 pi to positive 2 pi. So negative 2 pi, negative 3 pi over 2, negative pi over 2, 0 pi, positive pi over 2, positive pi, positive 3 pi over 2, and positive 2 pi. And now plugging the numbers in. What's the cosine at negative 2 pi? Well, remember cosine is x value over the r value, and my unit circle is 1. So really, I'm just talking about the x values here. Just like in sine, we were talking about the y values. Now I'm talking about the x values. What is the x value at negative 2 pi? Well, let's see. Here's 0. If I go negative 2 pi, there it is. What's the x value right there? It's 1. How about negative 3 pi over 2? Negative 3 pi over 2, what's the x value right there? 0. How about negative pi? What's the x value right there? Negative 1. Negative pi over 2, what's the x value right there? 0. At 0 pi, what's the x value? 1. At pi over 2, there it is. What's the x value? 0. At pi, there it is. What's the x value? Negative 1. At 3 pi over 2, what's the x value down here? 0. And at 2 pi, what's the x value? 1. All right, let's put it all together and graph it. Again, I can see that I'm going from negative 1 to positive 1. This time I think I got them in the right order. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative 3 pi over 2. Oh no, that should be negative pi. That should just be negative pi there. Here's negative 3 pi over 2 and negative 2 pi. I'm not going to stop the video and start again. I think we can handle this. All right. So let's see it. Negative 2 pi and negative 1. So there it is down here. At negative 3 pi over 2, it's 0. At negative pi, oh, I did it, didn't I? This should be a 1. I put it down here. This should be a positive 1. It should be up here, not down there. 0. Here is going to be negative 1. It's going to be down here. At negative pi over 2, it's 0. At 0 pi, it's 1. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And at 2 pi, it's 1. Sketch in my curve, and I should get a curve that looks something like... And again, we can see that a lot of similarities here. The domain, all real numbers. There are no domain restrictions. The range goes from negative 1 to positive 1. This is also a periodic function. The period of this function is 2 pi. The pattern repeats every 2 pi. Are they the same? Is sine and cosine the same? I want to take a closer look at that and explore that. It's a very important question. So what I'm going to do is I'm going to take my sine and put it on top. So I'm going to compare these two things on top of each other here. And I want to take a much closer look and just compare these two things. I want to make sure that we know which is which here. So I want to make sure that we know that this is the sine of x and this is the cosine of x. And are they the same? And the answer is no. No, they are not. Do they have the same maximum and minimum values? Yes. Do they have the same period? Yes, they repeat every 2 pi. What's the big difference? The thing that should jump out at you is the x-intercepts. The x-intercepts are different. Where the x-intercepts are very different. In sine, I've got 0 pi and 2 pi and 3 pi and 4 pi and 5 pi and 6 pi and so on. The cosine, I've got pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on and so forth. But the other thing that I want you to notice is, what if I took one of these and I translated it horizontally, shifted it, just translated it back and forth? If I took, for example, cosine and I shifted it pi over 2 that way, can you see how they would be the same now? Or if I took sine and phase shifted it horizontally, translated it backwards by pi over 2, like that. Now can you see how they would be the same? So a lot of similarities, but some very important differences between these two things. All right, questions? Well, I can't ask. I wish I was there to ask questions, because this is something we would definitely spend a lot of time talking about. But right now I want you to take out your calculator, and we're going to mess around with them on a calculator for a little bit. So on a calculator, go to our y equals. Oh, let's see, the calculator's not coming in very bright. Let me see, can I change that? Nope, that doesn't seem to be helping. I seem to have some glare. Let me see. I don't know if that's helping or not. I'm going to try to make my calculator a little bit darker. I don't know if that's helping or not. If I move it over here. Oh boy. All right, so anyway, in the y equals, so in my y equals, I want to put in just the sine of x and hit enter. The sine of x. I don't know how well we can see that. The sine of x in here, and then hit enter. Oh gosh, doesn't seem what I can do. That doesn't seem to be very good. The sine of x. And I want to make sure that I'm in radian mode. So I'm going to go to mode. Okay, I'm in radian mode, and then I'm going to go to zoom trig. Zoom trig is the preset window trig, and it'll give me. And there's my nice sine wave. Can we see that? I don't know why all of a sudden my calculators, I'm not doing anything different. See if my sine wave, trying to make it darker here, make it darker, make it darker. There's my little sine wave. So you should see a nice sine wave there. On top of that, now go to y2 and put in cosine of x and hit enter and graph it. And then you should see them side by side, kind of chasing each other. And you should be able to see the translations here. All right, the calculators doesn't seem to be working. I'll definitely try to make sure that I fix this part of the video for the next part of the lesson here. But I want you to play around with these things too, with the sines. Remember, we have the sinusoidal function. And the sinusoidal function is f of x equals a times the sine of b times x minus c plus d. Where, oh, now all of a sudden it's showing up. Oh, look at that. That's much nicer. I wonder why all of a sudden it showed up now. So if we want to play around with this, go back to your y equals here. I'm going to delete the cosine out. And what I'm going to do is I want to do the sine of x, close parentheses, and then I just want to graph just sine. So there we can see the parent function of sine. Oh, that's much better. We can see that. That's a lot nicer now. I think the contrast of the white paper is making it show a lot bit better. So now in y2, go down and I want you to put in the sine of x, close parentheses, plus 3. So plus 3, we made that d value into a 3 and hit graph. And what I want you to see is the only thing that happened is a horizontal translation. Everything moved up 3. That's all that happened here. Everything moved up 3. So if I go into the y equals now, I'm gonna clear that out. And of course, if I put down minus 2, it would move it all down 2 and everything like that. I'm going to leave the sine of function, the parent function in there, but I'm going to change my a value, and I'm going to make it 3 times the sine of x. So now I've got the sine of x and 3 times the sine of x. Here comes my parent function, good old sine of x, running back and forth. Here comes 3 times the sine of x. Now 3 is the amplitude. Notice what's changed. The maximums and minimums have changed. Instead of being -1 and +1, they're now -3 and +3, but the y-intercepts have not changed. They have not changed at all. It is crossing the y-axis at exactly the same place. All right, let's mess around with it some more here. So I'm going to delete out. I'm going to clear this one out. Now I'm going to do leave the sine of x in here, and now I'm going to put in the sine of 2x, close parentheses. The 2. I'm changing this b value here. The b changes the period, which deals with the horizontal stretching. So if I hit graph, here comes my parent function, sine of x. There it is. And here comes 2 times, or the sine of 2x. Notice the maximums and minimums have not changed. Still -1 and +1. But now the period has. The period is now pi. Going from negative 2 pi to positive 2 pi, I was getting 2 complete periods of sine before. Now I'm getting 4. It's just changed it a lot more. It's happening a lot more. And then C would just move things back and forth. So here, let's go ahead and change that. So now I'm going to do the sine of x and then the sine of, and I'm going to do x minus, and I'm going to do pi over 4. Pi divided by 4, close parentheses. So I'm graphing y equals the sine of x and the sine of x minus pi over 4, the c value, changing its phase shift, moving it left and right. So here comes good old sine. So now the next one that comes out is going to be the same thing, but ever so slightly changed a little bit. Notice pi over 4 has changed it a little bit, not enough to make it into a cosine wave. We'd have to change it by pi over 2 to make it into a cosine wave. But these values here, the A, the B, the C, and the D, very important characteristics. And I want you to play around with these things. Try different functions, try changing, see what happens if you do this and what happens if you do that. For the second part of the lesson is all about a specific example of these sinusoids. And we'll really get into the terminology, what are all these things. We're going to break this thing apart and look at a very different example in the next part of this lesson. All right, talk to you again in a moment.